all for being on time. This is the what is a service mesh session? Just in case you need to leave if you walked into the wrong session. But this is an Ask Me Anything or a Q&A style panel. So hopefully you guys came enthusiastically ready to ask questions. Otherwise, this is going to be a very short panel, very short session. Before we get started, let's introduce the panel. We'll start down there at the end.
Hey everyone, I'm William Morgan. I'm the CEO of a company called Buoyant. We're actually just about two blocks that way. We have an open source project called LinkerD, which is a service mesh. It's a cloud native computing foundation project used in production today at companies like Salesforce and PayPal and Credit Karma. And I'm here to entertain you with my opinions.
Hi, I'm Louis Ryan. I'm an engineer at Google. I work on an open source project called Istio. And we are not currently a CNCF project, though that's an active topic of conversation. Feel free to ask about that one. And it's like LinkerD and Conduit, which William mentioned, also a service mesh product that we have been developing in concert with Lyft and IBM and Red Hat and a number of other companies.
And I'm Christian Posta. I'm a chief architect at Red Hat. And I work with our customers to help them build cloud native architecture. So I'm basically Kubernetes up. And I like to contribute to interesting open source projects in my spare time, Istio being one of them. So I'm thinking maybe we could start off with since the name of the session is what is a service mesh, why don't we define what that is, and then we can go from there. William?
I have to start on all of these questions.
You do.
All right. What is a service mesh? What isn't a service mesh? A service mesh is a magical bullet that solves all of your infrastructure problems with no questions asked. I think we can all agree to that. And, well, no. So more seriously, a service mesh, we usually define it as an infrastructure layer that's dedicated to managing the service-to-service communication that happens in a microservice application. And by managing, I mean kind of the operational side of things. So things like reliability features, like how do we do retries and timeouts and circuit breaking and that sort of stuff. There's security features like TLS and identity that get passed across the service boundaries. And then also visibility, like how are the services operating. And the goal of the service mesh is to basically give you those things as part of the infrastructure rather than having to do it within the applications themselves.
Which means I don't need to worry about my retry logic and application layer.
Doesn't mean you don't have to worry about your retry logic to some extent, to the maximum extent that is possible without really knowing anything about kind of the semantics of the requests. For that particular case, for example, you might have requests that are idempotent that the service mesh just doesn't know unless you tell it otherwise. So yes, as much as possible. Yeah.
Don't think I'm asking silly questions.
Yeah. No, that was a great question. No, a really good question. Thank you.
Yeah, so I think William did a good job defining the general goals. We view it as an abstraction of the network so that the application has to deal less with the network. It has to think less about the network. Hopefully operators have to also think less about the structure of the network. And that becomes particularly relevant as the deployment size grows and the number of networks or network topology becomes ever more complicated. You don't really want any of those concerns bleeding up into the application layer. That would be a bad thing. Yeah, good job.
Today what we do is we know Hystrix code instead of our application and we handle it. But with service mesh we can take it out of the service application.
That's right. So you're saying you're using Hystrix today, right? And that's a very common starting point for this. Yeah. So Hystrix is a library that does things like retries and timeouts and some of the operational stuff. Yeah. The goal would be to move that out of the application and down into the underlying infrastructure. And then that has a couple benefits. I'll list some, and I'm sure the other folks can list them as well. But one primary benefit is around kind of polyglot applications. Hystrix is a JVM library, and so you have a hard time if you're trying to use it for node services or for Go services. If you move that logic down to the service mesh, then you can be polyglot, which is convenient for some companies don't care, some care a lot.
And that's important because you don't want the Java applications to think circuit breaking is this, and the Node.js applications to think it's something potentially different, and have this wide varying consistent problem of, well, we're trying to be resilient, or we're trying to be proactive about how we implement this stuff, but it's some of it is wrong, and that's a pretty bad situation at the end.
Right. Anyone who's managed a large production system has probably got some horror stories to tell about inconsistent retry logic. I've certainly got some good ones that I might not be able to share, but inconsistent, like exponential backoff, right, is a great example of something that people tend to implement in different ways, and those different ways can have very subtle and very damaging effects sometimes.
So who defines it? Is it an operational definition of the service mesh, or is it development, or a bit of both?
So it's usually a combination of both, right? I mean, usually, right, leaving aside the whole kind of operator versus DevOps model, right? You have people who produce services, right, and they're responsible, generally speaking, you want them to be responsible for defining how something else should talk to that service, right? That's what they want control over. And so, they have operational control over that. And the goal of the service mesh is to make it, one, to provide the features, and two, to make it easier for them to fulfill that role within the operational ecosystem, right? So your API should facilitate that process. Sometimes there's a negotiation between the producer and the consumer about what that configuration could or should do. And that's one of the interesting parts about the API design when you look at any service mesh product. But generally, it's a producer-oriented thing, right? My service, you should use affinity-based load balancing, or you should use round-robin or elastic-weighted load balancing or something like that, right? Because you know the properties of your service and how other things should talk to it.
It also offers multiple certain errors on user space and errors on different things. And can also flexible to configure the different
History? Oh, yeah.
Configured for service at the service mesh level, or does it become a global policy that everybody has to abide by?
So the goal of service mesh is to provide a uniform network abstraction, right? And then within that abstraction, right, you want to give operational control to different parties, right? So if I own a service and I say you should only talk to it this way and errors should be handled this way, then that's what I would like to happen. And I would rather not every other client in the network be able to violate those rules, right? So as the operator of the entire deployment, I'd like to be able to enforce that policy, right? There may be cases where you might say, well, okay, I'm going to carve out for that one consumer a different set of behaviors, right? And the API should probably provide affordances for that. But generally speaking, you want producer-oriented control over the network and operator control over who's allowed to override which policy.
And maybe another way to look at it is you want same defaults. You want defaults based on what the team that wrote the service to prescribe, and then for each individual consumer of the service, there might be, this is the 10% use case, right? The 90% use case is going to be the defaults that the provider has specified. The 10% use case will be, well, there's going to be these edge cases, there's going to be certain ways that the application wants to handle it differently, so they'll need input on those policies as well.
Right, and example, it's unlikely that you're going to have much variance in, say, load balancing or something like that, but you might have variance in policies that affect quality of service in some way, right? At that kind of L7 level, not the kind of TCP level of definition of what QoS is. You might allow a higher number of retries for a service that's production or user-facing than one that's internal or kind of staging, right? So those types of things might make sense.
There was a question here. Yeah.
Yeah, I was wondering, for say services that need really low latency, where maybe you don't want proxying or overlays, like you have really specific requirements, what's the best way to kind of try and integrate that into your mesh, or at least hook it on into some nice collaborative way with some oversight or visibility? Or is there a way to do that?
Well, every layer of abstraction you introduce, typically adds a layer of latency. And so depending on the application, like you kind of have to make a decision. Is what we're getting from this worth the cost? Almost every service mesh implementation today, though maybe not in the future, uses a user space proxy for like a lot of stuff. And that introduces a hop, potentially through the kernel network stack, although sometimes not even that. It certainly introduces latency through the proxy itself. So it's hard to make a one-size-fits-all statement. A lot of the adoption that we've seen with LinkerD specifically has been in companies whose services are taking, hundreds of milliseconds anyways, because they are, doing things or talking to a database, or and in that world, introducing an additional millisecond of latency or even additional 5 or 10 milliseconds of latency is not the end of the world, especially since the latency that you're introducing oftentimes can be kind of median latency, and you can, in some cases, recover tail latency and end up making kind of the tail cases that you care more about better by making effective use of load balancing.
Right, so I think the first thing is don't do it, right? I mean, you want to have the administrative control to say, when I talk to this thing, don't go through the service mesh, right? But you want administrative control over that, so you want to make sure that that's modeled in the API, and it's just, right, you know what's going on, and you can track it. The service mesh can obviously operate, at different layers of the stack, so maybe the service mesh could participate in, say, TLS handshake or something like that without actually being observing the traffic at layer 7. So you obviously have different knobs you can turn to control the latency characteristics of the mesh, and the resource overheads and the other types of taxes that William talked about. And I think it's going to be interesting to see over the course of the next 18 months to 24 months, people's expectations about certain classes of applications and their latency profiles and the features that get included in the mesh, like William alluded to, like doing some of this stuff in the kernel. You're starting to see some of those technologies come along. Not that I'm going to whip out a magic crystal ball at the moment.
The other thing I'll add is that a lot of what we've seen with LinkerD is the value of the service mesh is actually, in some cases, organizational more than anything else. So even though we're incurring this latency hit sometimes, we now have the ability to apply policy uniformly across all of our services. Each service is owned by a different team. The teams are all, kind of going on their own schedules. Asking every team in a large company to implement TLS in their service, for example, can sometimes be a very difficult task. But wrapping that all in a service mesh that can do that for you can solve kind of a difficult organizational problem. So, as with any technology problem, there's often a social component as well.
And it's probably worth pointing out that in some cases, service mesh, by increasing aggregate reliability or providing mediation for traffic, can solve certain classes of latency problems in a way that's maybe more thorough. If not necessarily more performant than any specific point solution, it can be applied in more places, right? Particularly things like caching. So, it's not something we do heavily in Istio today, but it is something that we've talked about doing. If you have a process and it's going to make 1,000 sequential calls out to Redis, it's probably not a great idea to stick to service mesh, right? Because the latency tax is probably going to blow up in that type of usage profile. But there are, in kind of high fan-out situations where you have a request that's fanning out through multiple hops down through many layers of a stack, having the service mesh in place, it can do things to improve the SLO of the system. And that can be a complex evaluation, right? Because you're now looking at all your service dependencies, how they're interacting, what are their failure modes. And service mesh's first goal is really to help you do that evaluation.
So in summary, magical bullet that solves all of your problems.
Magical cannon.
Magical cannon, that's right. Why stop? Why stop at a bullet?
So does service mesh only work within the microservices? Can you do like a circuit breaker to sort of legacy or external downstream systems you're talking to?
Oh, yes. Yeah, it's not a microservice mesh.
Yeah.
And hopefully, we studiously avoided calling, everybody avoided calling it that, right? Services are your mainframe. If you're going to call the Google Maps API, if you're going to call Salesforce's APIs, right? So both internal and external services, right? It's not just the things on your network. you can also configure how you should talk to the things that are outside. So kind of logically pulling them into your service mesh and putting them under your control. And that's a major goal of, well, both products as far as I know.
Yeah.
And it's the reality too, right? Not everything in, at least our customers, is microservice and cloud native and all that, unicorn and rainbow stuff. It's the brownfield stuff. It's the the Java EE app that's 12 years old, and you can't go in there and change it to add Hystrix and Ribbon and all, or any of that stuff.
Or mutual TLS.
Or mutual TLS.
Yeah, even in the fancy startup world that I operate in, it's like it's very rare to see a totally greenfield, like here we are, like Kubernetes and Docker and microservices, and like we don't have to deal with anything else. It's very rare for that.
So there was a question back there, and then we'll get to you, Scott.
So this is kind of the multi-cluster hybrid cloud use case with Istio. Yes, that's very much part of the roadmap. I think Cisco gave a demo at KubeCon last week of doing multi-cluster. Right now, the limitation in Istio is you have to be on the same RFC 1918 network to be able to bridge two clusters, or to have any two workloads, whether they're running in Kubernetes or in a VM or some other kind of orchestration framework, to be able to talk to each other. We'd like to be able to lift that limitation. There are things that we can do to make it easy to lift that limitation, so it's easier to span multiple VLANs or things like that.
And there's actually a talk that we gave yesterday, that Zach Butcher and I gave yesterday, on exactly that and exactly what Lewis is talking about. The demo crashed, so I'll be honest. It wasn't perfect, it crashed, but it's this close. It's this close.
I might need a service mesh for your service mesh.
Yes. For demos, at least, a demo mesh. Yeah.
But this goes back to the kind of the general abstraction, right? You don't really want your application code to have to think too much about network topology, right? And I've talked to a lot of large enterprises. They have sprawling network topologies with many VPCs and VLANs and things like that. And they could have the same logical applications sitting in many different physical networks. And they want the client of it to be able to talk to it, but they're trying to figure out how. And there isn't a good abstraction for it that's flexible. And service, one of the goals of service mesh is to just kind of make that network topology vanish, right? Applications talk to each other by saying, I want to talk to application named X. Okay, the service mesh will make that happen for you.
Right. Yeah, I keep coming back to layers of abstraction, just similar to how the orchestrator and the container kind of abstracted away this notion of here are my 5 servers that I have to treat specially, and each one has a unique IP address that I've memorized. Now I just have this pool of hardware, and I'm, and the mental kind of boxes and arrows diagram in my head when I'm thinking about my application is service A talks to service B, talks to service C, right? And I'm not thinking about, oh, here's the individual machines and IP addresses. Service mesh is, in a very similar thing. Like, I'm not really worrying about, okay, here's how the TCP packets flow from point A to point B. All I know is A talks to B and B talks to C.
I'd like to come back. There was a question about the enterprise stuff and talking to external services, which is kind of important. So far we've been talking a lot about kind of network abstractions, but one of the common use cases I see is, let's say you're paying to use SendGrid, right, as a mail service, and you have all your different applications, but only 3 of them are really supposed to be able to make calls to SendGrid because you're paying SendGrid tons of money, right? The service mesh also provides a control mechanism to say that, no, you can't talk to that external service, right? So you get that kind of operational control because all the network traffic is captured, and you have assurances that, basically your resources aren't being hijacked, right? And it's a very important operational behavior to have. So it's not just about retries and load balancing, it's also about operational control over access.
Okay, so you almost went to where my question was, which is taking that full circle of proxy, Tomcat, far back. Where is that in Istio? GWT support that stay in the future? Is that even something that should be in one here? Talk about security and access and resource utilization. Seems like something we get.
So I can talk about where Istio is today, and I'll let William talk about where that is in Conduit and LinkerD. right? So you have the mesh, and there is traffic that goes into and out of the mesh, right? So you have gateway-like functionality. Any mesh is going to have to be able to deal with those use cases, so that means you're going to have to deal with external end-user authorization models as well as service-to-service authorization models. So there's a lot of work that will happen in Istio to support those types of use cases. JOT support is there in Envoy today. So some of these pieces already exist, right? We have standard propagation mechanisms for it, but it's we're not doing all the things with it that we want to do yet. Then there's the kind of service level concerns, right? I have service A and service B and service C, and in Istio we model those, and in Kubernetes they're also modeled as running under the authority of a service account, right? And so we have RBAC that dictates at that level how authorities are allowed to interact with each other, right? So that controls service-to-service interaction. So we call that kind of coarse-grained RBAC. And Istio has support for that, first-class support for that. That should be coming out in the 0.8 release this week or next week. And we'll be making sure that's at beta level quality. But the more general thing is, right, you're going to have Istio and Kubernetes, and kind of Google's approach to this is to recommend a solution where workloads run under known authorities. Those authorities are allowed to get X509 credentials. Those we use with mutual TLS to do mutual verification between client and server. And then we can implement RBAC policies on top of those identities to control access to services. So that's kind of the service-to-service layer, and then you want to be able to layer end-user auth on top of that, and also be able to create correlations between end-user auth and service-to-service auth, so you can say, only certain services are able to call other services with end-user credentials, right? So that you can't have credential stealing, you can't have credential spoofing, and you limit the exposure of, say, a service getting compromised to be able to replay JOT tokens against other services within the mesh. So there's a whole long list of security stuff that should go on in that space. That is part of our roadmap.
Yeah, this stuff is all, there's a lot that's happening, and it's all fairly bleeding edge stuff. It's not stuff that the world has kind of figured out and like, okay, here's how we're going to, the world outside of Google at least has figured out. On the LinkerD side, we have kind of taken well, there's two answers. Like we've taken kind of the first answer is like we've taken kind of a hands-off approach where you can provide LinkerD with certs, and LinkerD will do the mutual TLS on either side, and how those certs get to LinkerD is kind of up to you, and what kind of policy layer you put on top of that is also kind of up to you. LinkerD will do the TLS and leave the rest kind of for you to build stuff on top of, and that's been a fairly successful approach. We have a sister project for LinkerD called Conduit, where we actually are doing kind of the opposite, where with Conduit, which is very Kubernetes specific, we are in the 05 release, which is coming up in, I think, probably 2 or 3 weeks from now. We're actually going to ship with the CA. The CA will issue the certs for you. The proxies will do the TLS. It'll do all the rotation. And the goal for us is you should do no configuration whatsoever and get encryption and mutual TLS. Identity, again, like wired through as a header, and you can do some kind of policy on top of that if you want to. And later versions of Conduit especially will have kind of more sophisticated mechanisms for expressing policy within the mesh rather than within the application. But that's all kind of service level auth. I think there's certainly a lot more interesting stuff you can get into once you start combining that with the kind of the other objects in the system.
And I'm pretty excited about the support for doing end-user type authentication in the service mesh. Because in the past, or even right now, the way we do that is with multiple different libraries for different programming languages and different frameworks that all are, try to talk back to that identity provider. And just like with Hystrix and Ribbon and some of these other resiliency aspects, we're kind of making it more polyglot by using the service mesh abstraction. We're going to get the same thing for that type of interaction with to verify end-user credentials.
Maybe I could expand a little bit. One of the other kind of corollary questions that comes up with this, the fact that the service mesh provides an identity-based authorization model, right, somewhat decouples you from traditional SDN-based network security models, right? And that's actually going to become a bit more important going forward in the industry, right? If you consider SDN models are very coupled to IP, but now you're starting to see, services, orchestration frameworks like Kubernetes or Lambda or any of the other kind of serverless frameworks, where they so rapidly schedule workloads that come up and down that, trying to manage destination IP as the locus of your access policy management is going to become very, very onerous.
Yeah, IP approaches meaningless. ST approaches, 0.
So, just to bring it down to earth a little bit, what's a typical service mesh deployment? Are we talking about a bunch of distributed components sitting on the same network? We're talking about a library kind of rolled into the JVM or otherwise, a sidecar on a Docker?
Yeah,
What
great
is service mesh
question.
implementation?
Yeah, great question. We can make this super concrete. I think they all follow kind of a very similar model, which is there's what we call a data plane, which is comprised of proxies, and the proxies are in kind of the hot path. So service A talking to service B will talk through one or typically two proxies, a proxy on the A side and a proxy on the B side, and that's the data plane, and those proxies are all distributed. So if one dies, it's equivalent to pod failure or to host failure, so you have mechanisms for dealing with that. And then there's a control plane, which is kind of sitting off to the side and talking to all the proxies and providing the human operators or the computer operators with kind of the API for controlling and inspecting the set of proxies as a whole. At least that's the implementation today. And of course, the devil's in the details, right? But the goal is for the application, ideally, it doesn't even have to know that the proxies are there. It doesn't have to know anything about this. It's just a transparent layer that's happening underneath. Sometimes it's not always possible to be 100% transparent.
Sure.
Yeah. Oh, okay. Yeah. So the question was, can you be very concrete about like how is this actually? What does this look like in practice?
And he's about to ask.
And now he's going to ask a question that's going to offend us.
Hopefully it doesn't offend anything, but how's that different from a federated service bus topology?
So the question was, how's that different from a federated service bus topology? For that, I will turn it over to Christian.
Did you write a blog post about this?
Good question. I think initially, so you're talking like enterprise service bus, this type of thing. So initially, the spirit of the enterprise service bus was transparently provide the communication backbone for disparate services for the SOA architecture. And that included things like protocol mediation and security, and some of the same things we're talking about right now, right? So your question is not offensive at all. I asked exactly the same question. But I also lived through, with our enterprises, both as an employee and as a vendor, the way the enterprise service bus actually manifested itself. It became this this walled-off castle with governance and everything that came crashing down, and you couldn't make any changes to anything that happened inside of that walled garden without all these approvals, right? So there was an organizational impact. The second thing was that enterprise service bus took on more responsibility than just routing traffic around and applying policies. We did things like transformations, business level content transformations, business level content-based routing. This message needs to go here because of this particular message content. And to actually implement that, you need to know you need the business logic in there. And so what we ended up doing was through reams of XML and very complex centralized products, we kind of pulled the application logic into this walled garden that as you tried to make any changes to the system, to your services, now you had to synchronize and coordinate with this central authority, and became bottleneck. So for some architectures, this ended up providing a lot of value, but as it started to evolve and grow and entropy built up, that became a source of frustration.
I actually have a question for you, Christian. Do you think there's a way in which that could have been done effectively? Like, is that?
What I'm more hopeful about this time is the focus focus on the impact in the organization. The way teams interact with each other is becoming more of a, we're shining more of a light on it as part of the problem that we're trying to solve than just, here, let's shovel another round of technology, right?
Great, I love that answer. Yeah.
So I think I'm more hopeful this time.
I have to plug my own talk for a second. I gave a talk at KubeCon EU last week called How to Get a Service Mesh into Production Without Getting Fired. The video is up on YouTube. It's me just like talking about my opinions for 30 minutes, which is extremely valuable and entertaining, obviously. So if you search for that, you'll definitely find it, and it was fun to give.
I'm going to ask you a question. When you say distributed service bus,
tables have turned.
Do you have some examples in mind?
Not that actually went to production.
Okay.
So a lot of them were R&D and theoretical. Back in, it's always been Oracle Service Bus, but back in the VA days where
Okay.
it came from, we're actually toying with it in a federated service bus where every domain, if you would, application domain would have a service bus component, and all interactions between these domains would actually have to go through the service buses.
Right.
So if finance wants to know something from vendor management, it doesn't need to know where it is, it doesn't need to know how to get it organized. Much along the lines of what you guys are describing about.
So to summarize the answer, yes, but they were all in R&D. None of them quite made it to prod.
Yeah, I mean, probably the one that I know that probably most closely maps to that today would be Nats, right? Or like if you look at Nats, or maybe, I've talked to a number of people who do Kafka deployments, they generally, right, they have all the edges are writing into queues, the queues go into some reconciliation point, and it's, either local or remote, distributed or not distributed, and then it comes back out of the queues and is routed back out to the edges, right? And the one that I've talked a lot to people about is the performance of these types of systems, right? And people often look at those as a means to achieve end-to-end reliability, and Google has a slightly different take on that because we favored latency at scale, right? And so you go point to point on the network, right? So that's how you maximize network bandwidth because you're not going into reconciliation points, right? You're also not going into physical queuing systems, right? Because going into and out of queuing systems has a latency cost that can be non-trivial. And you compensate for some of that lack of end-to-end reliability by having point-to-point retries, right? Which is what Google does in production, right? We don't write into queues and read back out of queues, for the overwhelming majority of our traffic. And you can still achieve very, very high SLAs with that model, right? While getting better utilization of your network because you don't have these choke points, right? And that's a distinct architectural thing from Christian's organizational point about organizational choke points, right? Because people like to control those reconciliation points, and they become paranoid about them becoming failure domains, right? Because they become single failure domains, right?
Centralized has been a problem.
Yeah.
Continues to be a problem.
Yeah. And most of the infrastructure that's available today to do point-to-point queuing, like you have Nats and ZeroMQ, which I think do a good job in this space, but Kafka and some of the more enterprisey products that people have traditionally used, maybe less so.
We're actually trying to do the same with Qubit Dispatcher.
Okay. Yeah.
How are we doing for time? Can anyone give us a time check?
When does this go until? 12:30?
Yes.
All right, plenty of time.
So if Istio is an operational thing, or at least it's an operational control point, how do you keep that from becoming in and of itself a choke point that delays the rollout of an app, or like it used to be, okay, you need to deploy my app, well now somebody has to go configure Istio endpoint or Istio, I shouldn't say service mesh, it's not a service mesh that goes along with that. That seems to me like that's kind of counterintuitive. When I'm deploying my services today, we're interacting with the world, like the project has an application, and then now it seems like I've got something else invading my project that has some external control that's not part of my project.
So most of the time, I mean, the goal is.
Repeat the question.
Oh, yeah, sorry. So how do we make Istio not an additional operational tax in addition to the requirements that I have today when I do deployments? And maybe let's use the deployments in Kubernetes as a specific example, right? Because it's a kind of good baseline point for discussion here. Kubernetes already has this problem, right? Where if I want to deploy an app, well, I have to interact with Kubernetes APIs, I have to reason about pods and namespaces and all the operational concerns. And it seems like the community in general has accepted those kinds of models. Wow. I don't know, should we all run? So, how do we, what are the things that we do to mitigate these types of operational taxes? So the first thing is the service mesh is supposed to be ambient, right? It's supposed to be on all the time without you really knowing about it. You only really interact with it if you want a feature out of it as an operator, right? So it's an installation time concern for the network operator or the Kubernetes cluster operator. Right? So most of the time they just install it, it's on, and every other Kubernetes deployment that gets pushed out just picks up the features, and the owner of each individual Kubernetes pod or deployment didn't have to think about it. Right? So that's the first goal. And the second goal is when you do want to interact with it, what are the types of things you're trying to get out, and what are your responsibilities within the organization? Right? Are you an operator or service producer? Are you a consumer? Right? How do we design the APIs so that those idioms are well supported and have a good end-to-end user experience? And that's probably the biggest challenge, right, is making sure that you can access the features that you want without having to take on all this other cognitive burden, right? If you want to control how traffic, is retried when making API calls to your service, you need a resource that lets you say that, right? So there has to be something in an API that lets you do it. So that's not entirely ambient, right? And then it's just about good API design. Right? And it's really just an extension of the kind of logical continuation of the Kubernetes model in this space. Right? Just like Kubernetes traffic policy lets you say things at the network level about how pods talk to each other, or what pods are allowed to talk to each other. This gives you a bit more control. There has to be an API for it.
So, in Kubernetes we have the DNS and the service. Where does service message comes with this? Like, does it sit on top of these or integrate with the services? And the DNS, we have service discovery. So, are we going to throw this into the service mesh or?
So kubedns, the typical use case is I have a service that I've declared, right? And the kubedns will serve the virtual IP, right? That the kubeproxy knows how to route traffic to and implementations of that pod. Service meshes do exactly the same thing, right? You try to talk to the service VIP, and the proxy will load balance across those set of endpoints for you, right? So that's the same thing, except the service mesh proxy will do that at layer 7 instead of layer 3, right? So now you can do much more sophisticated routing at layer 7, right? So there's a lot more control you get over the traffic, right? Which is most service-to-service traffic is using HTTP or some other layer 7-like protocol. So that's a major advantage for the service mesh. kubedns doesn't go away. kubedns is a service registry, right? I have a name and a set of endpoints. That's the same thing. It's a network control plane, if you will. Service meshes also abstract that out, right? We read endpoints, we read service names, push those into the proxy, we make sure that those routes work, right? So you could say that, the service mesh proxies are a replacement for kubeproxy, right? They can act as a replacement for kubeproxy.
So it's so you said it's an advanced networking instead of kubeproxy.
It doesn't, we don't physically, in the case of Istio, we don't swap it out. But instead of routing to service VIPs and letting kubeproxy do it, we route to pod IPs directly because there's no need to go through it because of the IP tables overhead.
And the shift from layer 3 to layer 7 enables a whole bunch of stuff. So not just routing, but also even load balancing can be done. You can balance requests rather than connections, and that makes a huge difference. You can measure the latency of individual pods. You can look at because you understand enough of the protocol to know whether a request failed or not. You can, for example, LinkerD can look at all the destination pods that are receiving traffic, and if one of them is slowing down, it can shift traffic away from it. If one of them is fast but is returning 500s, it can kick it out of the load balancing pool. It can make all these decisions for you, and in some cases, things can be, going south for a while without you even noticing because LinkerD is picking up the slack. So the shift from layer 3 to layer 7 makes a big difference.
And this service mesh concept is sort of the evolution of what Kubernetes kind of started. Kubernetes is really good at cloud native deployments, and there's some basic rudimentary support for load balancing, service discovery, that kind of thing. But the next evolution of these applications has to live somewhere, and Kubernetes is, they're going to keep their core, make it stable, and they're not going to try to tackle the world. So this is where service mesh comes in.
So it's advanced services.
Advanced service communication.
Yeah, sometimes we say internally that Kubernetes has kind of solved deploy time operations, and the service mesh is solving runtime operations. Not 100% right.
And like, I encourage you to go look on the Kubernetes SIG network mailing list, because there are active discussions about like how that side of Kubernetes is going to evolve and what the right operational stack is, which is a dialogue that I'm certainly actively involved in. And all these concerns, right, are these advanced networking concerns are ones that the Kubernetes maintainers want to see addressed, but they're not sure if it should be part of the stack or go and use one of these products to kind of layer that stuff in for you. But generally, there's recognition in the community that these types of products are absolutely necessary at the networking layer.
There's a lot of talk about network topology and connectivity and that sort of thing. Is there any limitations with the types of messages that are going through? I mean, SOAP, REST, JMS, even mass file transfer. Is there any limitations in the type of messages you can send?
So the question was, are there limitations in the types of messages that can be sent? For us, it's good messages only, and bad messages not allowed. No, I think generally speaking, it's anything that goes over TCP is okay, like should be able to go through the mesh. There are certain protocols often where if the message is in these protocols, then the service mesh can do a bunch of stuff for you. So in the case of LinkerD, HTTP, HTTP2, gRPC, like those are all things where we can do request level balancing and things like that. If it's something else, we can give you kind of, if it's not one of those protocols, but it is still a TCP message, we can give you byte level, metrics on stuff, but we can't do anything fancier than that because we don't know enough about the protocol.
So one thing I would add to that, and I don't think we're there yet today, but the service mesh should also make it relatively straightforward for operators to be able to inject bespoke protocol understanding into the network. Right? So you can write a parser for the framing format of MySQL, right, and use that to extract telemetry about the behavior of MySQL requests, right? So treating MySQL as a layer 7 protocol, because it really is a layer 7 protocol, it's just there aren't that many products that support it at layer 7. And so if we can do that type of stuff, right, then you can start to get more and more value out of each of these protocols, and maybe you don't want to do, you don't want the service mesh to do retries for MySQL, but you'd certainly like it to extract telemetry. Maybe you might want to do splitting, so you could route reads versus writes to different shards, right? So
maybe you could implement some cool business logic in there.
Some transformation.
Yeah.
Business logic gets everywhere.
You can parameterize it with XSLT.
Sure.
Since I think we're reaching the end of our allotted time frame, should we do one last question or a round of summaries or 1 feat of physical strength? V1. Wow, V1 is meaningless, but
Yeah.
yeah, okay, so if
Ready,
we get to
set,
production ready, definitely conduit. And with that, we're done. So the question was, how do we test it?
Lots of effort.
Yeah. I have a 30-second answer to this, which is that we've been putting LinkerD into production for about 2 years, and if there's one lesson that we have learned about that, it's that you need a lot of diagnostics in LinkerD itself, because the moment you introduce it, everyone blames it for everything that goes wrong, and 90% of the time they're wrong. 10% they're right, 90% of the time they're wrong, and in production, you always run into weird things that you never ran into in staging, because something's different about the layer 3 topology or something else is involved. So you test it like any other software project, plus a whole bunch of diagnostics in production.
Yeah, so I mean, generally speaking, aside from the normal best practices around incremental rollout, the goal of any of these products when you turn them on is they should have no observable effect, right, on the behavior of the network, except for the fact that there's now telemetry about what's going on in your network, right? So it should be a quiet launch,
Yeah.
right? If we're not quiet launching, right, you have reasons to yell at us.
Yeah.
It's when you start doing things, all right, and that the pain point, right, making sure that we expose telemetry out of our system so that, as rollouts grow in complexity and operational complexity and network topology and all those areas, we will run into issues. But the goal is ultimately to, the first phase is always a quiet launch, and then you turn features on and observe their impact incrementally. Right? Just like if you went and turned on an overlay network, right? Maybe you want to go use Calico or Flannel or something like that when you're using Kubernetes, right? It's supposed to be a quiet launch. That's the goal.
All right, with that, I think we're out of time.